Welcome back. We are looking at filtering lists in lesson 4.2 today, or this lesson here. Let me go ahead and share my screen. And we're looking at lesson 4.2, filtering lists. The objectives are that students will be capable of filtering lists with a conditional statement in a for loop. And students will be capable of filtering lists with a conditional statement in a list comprehension. I'll just say from the get-go that the list comprehensions are hard. So if you can't figure them out immediately, don't sweat it. Don't stress. If you can't figure out what the for loop, then just stick with that. Well, both ways filter lists. And so we'll look at both ways. Number one, filtering lists with the for loop. The logic is pretty simple. What you have is you have some big list with a bunch of stuff, a bunch of elements in it, right? We want to just pull out some of them, not all of them, but some of them. So we're going to traverse over, that is loop over the list. And then as we're looking at each element in turn, we'll say, does this current element meet some condition that we want it to meet? If so, then append it to another list. And we create an empty list that we'll call an accumulator or a collector. It's going to collect elements out of another list that meets some conditional test, some criterion. Okay, like I mentioned, we're going to loop over the list that already has stuff in it. During each iteration, that is during each time we're looking at one element in the list that already has things in it, we'll determine if that current element evaluates to true in some conditional statement. If so, then we'll append it over to the empty collector list. Okay, that's what this last statement here says. And then move on to the next thing in the list that already has things in it. Okay, so let's take a look. Jumping right into practice. Using the technique of filtering lists with the for loop, define a function that takes as input a string and returns as output a list of repeated words, if any, in the input string. If there are no repeated words, the function should return the special value none, which is a special value in Python. Next, write a program that uses the function and then ask the user for a couple of sentences about him or herself and prints any repeated words. This is a two-step process. First, we're going to define a function that does this, that takes as input a string, returns as output a list of repeated words, if any. Then we write a program where we use that function and we ask the user for some input, and then we print back to them any repeated words. Okay, so take a stab at that, give it a try. Pause the video and give that a try. Just if you can't even know where to begin, at least just try and think through what should happen. I don't know how to do it with code, but what should happen? Like what are the steps that need to happen here? Okay, so pause the video and give it a try for a bit. Pause. All right, let's take a look here on how to do this, or one way to do this. As I've mentioned several times, there are many ways to do things with computer code, and this is one way to do it. It is more involved, has more lines of code than our pretty simple things before. Okay, so the first thing is we need to define a function like we saw in the last lesson. So here on line 2, I have the function head. I decided to call the function has duplicates, right? So I have the keyword def for define, def. I decided to name the function has duplicates. I have open parentheses. I have input string. I decided to use the variable name input string as the argument that comes in when the user calls the function. Then we have a colon. Then once again, all the rest of the lines in the function body are indented, one indentation, all the way down to here. So each of those lines is indented, one indentation. Okay. And let's walk through the code a bit here. First thing, this is where comments are useful. First little block here says convert string to uppercase, straightforward, right? We push everything to uppercase. So we don't have to worry about uppercase and lowercase being considered different things. which computers do. Next, we want to split up the string into on non-characters, non-letters, that is. So the caret symbol at the beginning of the character class, the brackets. So right here, there's a caret on line 9. Okay, so let's read through this. This says we're going to import RE because we're going to use the RE function split, re.split, which takes as arguments a regex here, then comma, then the input string, and then here I give it the flag. Don't worry about case, ignore case, do a case insensitive split. So it could be uppercase or lowercase letters. Okay, so with this, let's just read through this. Here's the regex, the R before the opening double quote. We have square brackets here, right? Which means a character class. The caret means not one of these characters. So split it up on not one of these characters, that is on non-letters. You can give a range of letters with a dash. So I say A to Z. If I wanted it for some reason like A to M, whoops, one second. If I wanted it A to M, I could do that. It would only go from A down to M. But anyway, so I want it, or excuse me, non A to M since I have that caret, right? So it says find some non-letter character and split up this string on those non-letter characters. And so we get a list back that has words. I call it words here, right? I decided to call it the variable name words because that's basically what it's holding. Okay, then the next little block sorts the words in alphabetical order, right? I use the dot sort list method. This modifies in place again, so you don't have to save it back to itself. And if you tried, it would cause problems. All right, so no need to save it back to the variable name. And then, okay, so we have our list that has stuff in it. Words now has words in it. Okay. Let me just stop. Let's take a minute here to stop. Let's just keep arrowing ahead. And I will show you here in a minute that words has, it's a list that has stuff in it. Then we create our empty list in order to add repeated words to it. It's referred to as like a collector or accumulator. So I'm going to call it on line 15 here, repeated words equals open close square bracket. Mine, that is a square bracket here, not parentheses. Okay, make sure you're understanding when you should use square brackets and when you should use parentheses. In this case, we need square brackets. We're creating an empty list that's going to collect things. We're going to push things to it. All right, so here we're going to loop over the indexes of the words in the words list. Okay, so here's a function that says, what is the length of words? And it just gives me a number. If there's only one word in there, then it says 1. If there's 20, then it says 20. So the range function gives me an object that has from 0 up to that number -1. I go from 0 up to 19 if it had 20 words, for example, because the 20th word in the list actually has an index of 19. Once again, because Python is a 0-based indexing language. So I is going to hold the current index. All right, so we're going to jump into a for loop here. Here's the for loop head on line 18. Okay, and I say if on the first word, jump to the next iteration of the for loop. So that is jump to the second word because it can't be repeated if it's the first word, right? So there's no reason to even do anything with it anymore. Right, so 21 says if I equals, mind the 2 equal signs there, 2 of them, 0, that is we're on the 0th index, the first word, continue. That's a special keyword that says jump to the next iteration of the for loop that you're in, which started on 18, right? Okay. And then we say, okay, if the current word is identical to the previous word, add the current word to the collector list. Now, why would that be the case? Well, because we sorted them. We sorted them right here on line 12. we got a string, we broke it up into words, and then we sorted them in alphabetical order. So if we have repeated words, they'll be next to each other, right? If we have two those two those will be next to each other in that sorted list. So we're just gonna look at the previous word and say, okay, if the current word that you're looking at, right? So this right here says words index into I, right? So words is a list that holds all the words, and the I is a variable in the for loop that's looking at each word in turn. We say if the current word is equal to two equal signs, the previous word, that is I minus one, so the word that had the previous index, that is the previous word, then we want to append to the repeated words list the current word because it's repeated. Once again, the dot append list method modifies in place, so there's no need to save it back to its variable name. Okay. So now, once again, this is hard to see, but this indentation right here on 18 is the same level as this if statement on 29. You can see that pie chart a bit, kind of see the pie chart has a vertical line there that helps us see, okay, yeah, this is at the same level of indentation, which means that this for loop will finish running through all the words before it comes down and runs 29. If 29 had been indented one more to the right, it would actually run during the for loop, but we don't want it to do that. We want it to go through the for loop, all the words, populating the collector list. And then once that's done, then we go to 29. It says now, after the for loop has finished, mind the indentation, see if the repeated words list has anything in it. And if so, return that list to the user. Otherwise, return none. So we say if repeated words, if there's something in there, then return those words, return that list back to the user. But if there's nothing in repeated words, then return the special value of none. Okay. So here is the main program. So once again, all this was just simply defining the function. From line 2 down to line 32, this was simply defining the function. It wasn't calling it yet, wasn't doing anything with it. Now here's the main program, starting on line 35, 36 right here. So we use our good old friend input to ask for some input from the user of the function, yourself, for example, if you run it, which you will here in a second. And then on 37, we throw whatever they give us into this function has duplicates, right? Has duplicates is the name I gave the function up here on line 2. That's the name I decided to give the function. So I'm calling the actual function down here on line 37. Okay. And then I save the output to a variable called rep words. There on 37. And I say, if there's something in rep words, then tell the user that you repeated the following words on 39. And then on 40, you actually print out those repeated words. But if there's no rep words, if it returns none, because there were no repeated words, then it will print out to the user, you didn't repeat any words. Congratulations, you on your breadth of your vocabulary, the breadth of your vocabulary. Okay, so let's try this. I'm going to run the script, keyboard shortcut, and let me expose here the console. So it says, please write a couple sentences about yourself. Let me say, I'm Earl Brown. I'm, well, let me put I am, because the apostrophe is going to cause problems. It's going to split up on that, which I don't want it to do. Okay, let me just write I am so that we get repeated words here. I am Earl Brown, and I am a professor, associate professor to be quite exact. We should get professor twice. We should get I twice, M twice, of linguistics, specifically computational and corpus linguistics. Okay, so we should get linguistics a couple times, right? Great, there we go. So it says you repeated the following words, and linguistics and professor. Now I'm not sure why I didn't get M and I twice. Let me pause the video and figure that out real quick. Okay, yeah, I figured it out. Let me share my screen again. Well, I'm not sure. Honestly, I'm not sure why it didn't show me M and I previously. I think it might have had to do with the fact that I was cutting and pasting within the string that I was giving it. Anyway, so I reran it. And one thing I did, there's a debugging technique where you just print out a variable to see what the variable has. And so after I sort the words here on line 12, I just created a new line called print words so I could just see what words has at the moment. So when I ran the script, it printed out what words had at the moment, which I can see, okay, yeah, it's got M twice, it's got I twice, so why wasn't it printing those out? Anyway, when I ran it again, it did actually give me M and I, as well as and, linguistics, and professor from the string I gave it. Okay. So that's a really useful technique, is simply print out what a variable has, what the value that a variable holds at the moment, so you can see if it has what you think it has. One of the main ways of debugging, one of the main challenges of computer programming is problem solving. I mean, that's the name of the game, is problem solving. You're almost always gonna have bugs, and you have to work through the bugs to figure those out. By the way, bug in computer speak comes from an actual bug that got into a mechanical computer like in the 1940s, I think it was. And that term has just been used since. Okay, so if you'd like to pause the video, I can't display the whole code at once. So just look at go ahead and take a look at the solution file that I have on the CMS. If you'd like to pause the video and make it work on your end, I would encourage you to do so, to make it work on your end, and perhaps print out things at certain points in the script to see what values variables hold. Okay, so pause the video if you like. All right, let's take a look. Modify the previous program to print back to the user words that begin with the syllable structure CV. That is a consonant followed by a vowel. So CV syllable structure is the most common syllable structure, probably pan-linguistically, cross-linguistically. So modify your program so that it prints back to the user any words that begin with a consonant followed by a vowel. Okay, once again, you have to iterate over all the words that the user gives you and do a conditional statement. Say, is the current word, does it begin with CV, a consonant vowel? If so, add it to the collector list and go through all the words. And if you have any in the collector list, print them out to the user. Otherwise, return none. Ready, set, pause. All right, let's take a look here. How I go about doing that. All righty, here we are. Let's walk through the code a bit here. So again, good old fashioned function definition head, keyword, function name that I give it, any arguments that come in from the user, colon. Everything else is indented one indentation all the way to the end of the function definition on line 16. Okay, so let's look through. So I import RE, good old friend RE. I split up the string on a regex that I give it. And it's the same regex as we saw before. That is something other than a lowercase letter, but actually it doesn't matter because I pass in this flag of re.uppercase I, which is shorthand for re.ignore case. So it could be uppercase or lowercase letter, English letter. Split up on those on non-letters, this string, so that we end up with words. And then create an empty collector, an empty list. Once again, mind the square brackets here on line 8. Those are square brackets. And then loop over the words in the list that we created on line 6, right? Words holds a list of words. I'm going to give it the variable name word. When I'm looking at each word in turn, I'll be looking at the variable name word. Make it transparent there. But once again, this could be any variable name that's well-formed. But you'll often see this in Python. You'll see a plural for a list that holds many things, and you have a singular form of that plural noun. for when you're looking at each one in turn. So here on line 9, we start the for loop and we say, if RE search, if you find, here's a regex. Okay, this is a little review of regex. We had a nice lesson on regex, and I think we even saw this regex itself. So we say, okay, here is an R, right? So that starts the raw string or regex right there before the opening double quote. It could be single quotes, by the way. Then we have \b, which is word boundary. You have a character class between square brackets here. So it says one of these characters, but because we have the caret before the first caret, it means not one of these. So give me not one of those characters, not one of the 5 orthographic vowels, one of them. And then we have another character class of the 5 vowels, the 5 orthographic vowels, right? And so we should get a word boundary that is beginning of a word, something other than a vowel, followed by a vowel, followed by \w. Remember what \w is in regex? Alphanumeric character. Give me some alphanumeric character and the asterisk 0 or more times. Okay. So we're looking for words that begin with CV, consonant vowel. And we're looking at each word in turn. We're evaluating each word, saying, is that the case? Is this current word one of those type of words? If so, then line 11 will run. And line 11 says, okay, here is the name of the list that we're going to push things to. Append is a list method. We're going to append the current word to it on line 11. Okay, so because the indentation of line 9 is the same as the indentation of line 13, lines 10 and 11, right? This for loop from 9 to 11 will run completely, go through all the words before it gets down to 13. Then we say if there's anything in your CV underscore words list, then return that thing out, return it back from the function call. Otherwise, if there's not anything in the CV words list, return the special value of none. Okay, so there we go. That's the function definition. Once again, we're only defining the function right here from lines 2 down to 16. And then we test the function with this little bit of code down here on 19 and below. So on line 19, we ask for input from the user. On line 20, we call the function we just defined, passing in the variable that's holding the input, right? We just decided to use the word sentences as the variable name. We pass it into the function call, and the result we assign to the variable name output. We say, if there's any output, then print this stuff, these 2 lines. Line 22 says, here are the words that have CV syllable structure at the beginning. And then line 23 actually prints out those words, the list of words. But if there is no output, like there's the none, right? If there's that none special value that we assigned perhaps right there, then it will say you didn't write a single word with the CV syllable structure at the beginning. That's hard to do in English and many other languages. So let's run this. I'll just grab the same little bit of text I used on the previous activity. Let me just throw this in here. So there's the same thing. I am Earl Brown. I'm a professor of linguistics. Okay, good. So here are the words that have CV syllable structure at the beginning. Linguistics, yep. LI. Computational, CO, yep. Corpus, CO, yep. And linguistics, there they are. Is that it? Yeah, see, I didn't control for capitalization, so it didn't, well, that would have, those are 2 vowels, those are 2 consonants, I would have gotten that anyway. And was not found, right? M was not found. Professor was not found, that's 2 consonants at the beginning. So yeah, specifically has 2 consonants at the beginning, SP. Yeah, so it got all the words that it should have gotten, all CV words. that begin with consonant vowel. All right, so if you'd like to pause the video and make this little program work on your end, be a good idea. You actually can't see the whole function definition here. Might be easier just to open up the solution file and copy and paste and just analyze and say, okay, what's this doing? How does this work? Maybe print out CV words occasionally within the function definition. Okay, but if you like to, I would encourage you to make this work on your end, not just watch the video and move on, but make this work, that learning happens with you struggling to make code work. All right, pause the video if you like. All right, let's try another modification of the program. It says modify the previous program to print words, if any, that begin with the negative prefix in, im, or e, or I, right? As in inadequate, impossible, irreal, and illegal. Irrealis. Irreal. That's irreal. Yeah. Anyway, just a little linguistic lesson here quick. If you have a bilabial consonant like P, possible, both of the lips come together to create that sound, you'll get an M, orthographic and auditory M. But if you have something else, you get an N, but that N can assimilate to the place of articulation of other consonant. Anyway, just go ahead and look for in, im, or the letter I at the beginning of a word. With the idea, we're trying to find this negative prefix that negates the word, right? We're gonna get a lot of stuff that's not. We're gonna get a lot of false positives. We're gonna get a lot of words that likely will, that aren't actually that negative prefix. But this is one way to try and find it. Okay, so pause the video, modify your program to, or create a new one, copy and paste it if you want to keep kind of a track of all the programs you're creating now, which is actually a good idea. Go ahead and pause the video and try this program. Ready, set, pause. All right, let's take a look. Welcome back. Take a look at how you could go about doing this little program. Get this code. Okay, let's look through the code here. I define a function starting on line 2. There's my function head. We've seen this quite a few times now. Keyword def, function name that I give it, open parentheses, variable name that we'll use. That's the input string that was coming into the function, colon. All the rest is indented, one indentation. All the rest of this function definition, that is, right, is indented, one indentation. And that's how Python knows that your function definition ends, is because the indentation is not the same, meaning it's not indented anymore. Okay, so we go ahead and split up into words. We've done this several times now. I'm not going to take time to explain this in detail. We've seen this before. We create an empty list. That's a collector. We loop over the words. Here, the only really difference here is the regex. Let's look at the regex closely. This bit right here. We have our good old R right before the double opening quote. We have \b, which means in regex language, word boundary. Then we have an I. Right, we actually want an I at the beginning of a word. Right after the word boundary, we want an I. And then we have square brackets. We have square brackets there, right? And so we want one of these letters. Okay, one of them. Either M or N or R or L. One of them. And then we want those one or more times, because we could have two R's, like in irreal or illegal. We actually get two L's in illegal and two R's in irreal or irrealis. That is unreal. That is irreal. I hear ir more in irrealis. But anyway, so we're saying one of these, then we put the plus sign there, which means one or more of the previous thing. That is one or more of these, one of those. And then \w is alphanumeric character, one or more times. So we want a word. So we should not get the word in, for example, because we have a plus sign there, which means we need at least one more alphanumeric character after the I and after the N. right? That's the only difference really from the previous program. I mean, I changed the variable name here holding the collector list, right? I changed the function name to neg in words, negative particle in words at the beginning. But all the rest is the same from the previous program, so I'm not going to take a whole lot of time to describe that in detail. Same thing here, get some input, throw it into the function we just defined, grab the output, save it to an output. I just call it output, the variable name, and then print it out to the user if there's something there. If not, say you didn't write any words that might have the negative prefix in at the beginning. Let's run this little script. Now I'll just go ahead and paste. I lost it. I didn't save it. I am Earl Brown. I'm just going to do that real quick. Yeah, so it said, hey, you didn't write any words that might have the negative prefix in, im, or I at the beginning. Let me run it again and do that on purpose. So I'll write down here, it's impossible to believe that computers can analyze language so quickly. Okay, there we go. It found impossible there. It says, here are the words that might have the prefix im at the beginning. Yeah, it found impossible. Let me just save that little bit of text there, rerun the script again. I'm using the keyboard shortcut to do that quickly. I'm going to just put the word in here anywhere. It doesn't really matter. This doesn't make sense here, but I'm just going to put the word in whatever. I just want to show you that in should not be found. So the word in was not found, right? Once again, because we had a plus sign right after that W, which means we need at least one or more of that alphanumeric character that comes after the N, which comes after the I, which comes after the word boundary, right? If I change this to an asterisk, it should get that. Let me grab this little bit of text real quick. This now should get the I, or excuse me, the N. Let me just paste in that string. So it should get impossible and it should get in now. Yep, it got in now, because it didn't have to find anything after the N of in. But if we want to make sure it's a prefix, not its own word, we need that plus sign after the \W. Okay, so if you like to pause the video, I'd encourage you to pause the video, make this work on your end. There you can see the full function definition. The main difference from before is just the regex here on line 10. All right, pause the video if you like. Okay, so that is how you filter words or filter things, in this case words, out of a larger list in a for loop. You just loop over that for loop and use a conditional statement. If something, evaluates to true, then append it to the collector list. That's how you filter through lists with a for loop. That's the first objective. If that was tough for you, then honestly, you may just want to stop the video now and just really get that down. Just practice that for a good number of minutes or half hour to an hour. Just get that down. If you're ready to move on, then look at list comprehensions. These things are cool. They're kind of harder to parse out as humans. Python has no problem parsing them out, but they're a little bit harder to understand. But here we go. Now we're going to do the same thing. We're going to filter out lists with list comprehensions. Here's some examples from the book, from chapter 19, section 2, list comprehensions. Okay. So they have it within a function like we just did. What we want to pay attention to is right here. Okay, so we have right here on res equals square bracket. Let me make this bigger by going like this. Make this much bigger for us. Oh, that's a little too big. Okay, so here we have an empty list, right, that we assign to the variable res for results, I guess. And the empty list is created by the open close square bracket. Then we loop over the list that came in. Well, in this case, it's a string. A string is a collection like a list is, and so you can loop over each character of a string by just throwing it into a for loop like this. So they're calling the variable that will be used within the for loop s, looping over T, which is a string. And for each variable, for each character, they're going to capitalize the string and append it to the collector list. Once again, this dot append list method modifies in place, so you don't need to save it back to its variable name. You should not say res equals res dot append. That would cause problems. You just simply append it like that. And then you return out from the function the results. Okay, so that's the way we just saw it, how to do something and saving it to a collector list. But we could do that more succinctly with this. This is called a list comprehension. It's a little bit more wild. It's kind of like writing a for loop in one line. Okay, so we say, okay, here is the variable name. It's actually kind of easier to look at it right here. For s in t, so that's the same as we saw before, right? For s in t, that's how you start a for loop. Let's look at that first. For s in t. So we're going to loop over t, and during each iteration, each element of t will be assigned to the variable s, because we're saying for s in t. And then during each iteration, we want to capitalize s. That is, each element of t we want to capitalize. And we save all that to a list. That's why we have square brackets there. Okay. So once again, this is kind of like a one-line for loop that returns a list. Okay. You can only do this when you want a list back, and the code is short enough that you can do it basically on one line here with the list comprehension. Okay. Let's take a look at another way of another application of list comprehension. So let me back up here. So this right here actually is what's called mapping a function to each element of a list. So we're mapping the capitalized list, we're mapping the capitalized string method to each element of t. And we're saving a new list that has an uppercase version of each thing in t. We can do that more succinctly with this. All right, so we're mapping this capitalized function, which means applying this capitalized function to each element of t. You can also do filtering here. So like we saw previously, when we want to filter a list with a for loop, first thing we do is we create an empty for loop. Then we loop over the list that has stuff in it already. And then we do some conditional statement. If s is upper, then we want to append it to that collector list with dot append. When that's all done, it returns it out of the function. This can all be done on one line with list comprehension as well. So I will start right here. Let's look at this little bit of these four words here. We have for s in t. That should be familiar. We see that all the time with for loops, right? For variable in collection. So for s in t. All right. Good. And then we want everything. So we say for s in t, which means we want every last element in this t list or collection if, then we have an if statement. If the current thing is uppercase, right? And so we're identifying the current element with s because we said so right here. All right, so we want every last thing in this list if each one is uppercase. So it's only going to get the uppercase one, the uppercase words. And like they say here, list comprehensions are concise and easy to read, at least for simple expressions. They're usually faster than the equivalent for loops, sometimes much faster. So if you, okay, wait. But like I said, this is a little bit wild. If you're still struggling with even for loops, just how to do for loops, then just stick with for loops, the for loop way of filtering list, like we saw back here, right? Filtering list with the for loop. Just get that down. But if you're ready to move on to list comprehensions, let's try some. Let's try this right here. So practice. Write a list comprehension that creates a list with the first characters, or the first character, that is just the one first character of the words in the following list. Okay, so there I give you a list. I give you a list with 5 elements. I call the list numbers. You can see it's a list because I have square brackets right there, right? Make that bigger for us. Those are square brackets. Identifying a list. And there are 5 elements. There are 5 strings. We know they're strings because there are quotes around each one, right? Quotes around each one of these things. So those are strings. 5 strings in this list. So write a list comprehension that creates a list with just the first character of each of those 5 words. Okay, so you're gonna need string slicing. If you can't remember that, go back and review the lesson about string slicing and string concatenation. We used that quite a bit there. All right, so pause the video and try this practice exercise for a few minutes. All right, let's take a look at how I would approach this with a list comprehension. This is quite concise. You'll see here, it's very concise. There it is. We have the list that I gave you in the lesson plan. You can just copy and paste it into your script like I did on line 2. Then here on line 3 is where the list comprehension happens. We can see that it's a list comprehension because we have square brackets on either side, right? We have the square bracket right there. They're highlighted in yellow on line 3 of my pie chart right now. So list comprehension. Okay, let's look over here on the right side. We have 4 variable in list, right? So I'm going to give it the variable name word in this list that was defined on line 2. Okay. And on each of those words, I only want the first character. So I'm using the indexing I'm using the index notation there with the square brackets on the right side of a string or a variable that holds a string, right? So there you have it. Give me the first character, that is the 0 indexed element of the string for each word in numbers there. So if I run this and then save it out to a variable called new list, and then on line 4, just print that new list to the user. Let me run this script. There we go. Down here in the console, we have OTTFF. Yep, O for 1, T for 2, T for 3, F for F5. Yep. There we go. So if I like to pause the video and look at that, once again, if that's out of your wheelhouse, if you want to try and solve this problem with a bigger for loop, where you have a collector list and you go through a for loop and you're appending things, you can do that if you like. In fact, I'll do it real quick. It's not that onerous here. Let me just go ahead and comment those out and do that. So let's create a new collector list that will be empty to begin with, right? Then we jump through each word. I'll just use the same variable name, word in numbers. Okay, and then we're going to append. Well, I'll even break it down even more. First character of the current word is obtained by indexing into that 0 index, which is the first character in the word. Once again, Python is a 0-based indexing language. So the first thing in the collection actually has an index of 0. And then we want to append this thing like that, first char, let that run all the way through. So I'm going to come back and indent over to the far left and then print out new list. Let's see if that works. Yep, has the same result, OTTFF. Same result, right? So a little bit different approach, but gives you the same result. So like they say, this list comprehension is more concise. I mean, you can see it's more concise, many fewer lines of code, and actually, I believe runs quicker on the computer than regular for loop like that. All right, if you'd like to pause the video and take a look at that or compare the for loop and the list comprehension, you can do so now. All right, let's try a new one here using the same numbers list from the previous exercise. Write a list comprehension that creates a list with only words that have an E in them. Okay. Give that a try. Pause the video and see if you can do that, where you write a list comprehension that creates a list that only has words that have E in it, in them. All right, let's take a look at how I approach this one. Let me grab this bit of code and let's take a look. So there's the same list on line 2. Line 3 has list comprehension. Once again, we can see that it's a list comprehension because it has the square brackets at the beginning and end, right? In yellow now, they're highlighted in yellow at the moment on line 3. Okay, so here, let's look, I'm gonna highlight first what we see in regular for loops. For variable I, in this case, in collection numbers list in this case. Okay, so we know that the variable I is gonna hold each element of the list in numbers, right? Each element of the numbers list. So we say I for I in numbers, which means give me every element of numbers, but then we give it a conditional statement here. If the letter lowercase e is in I, once again, I is holding each one of these elements in turn. So it's going through and looking at each of these in turn. And so we, in the end, we only want words that have an E in them. So we should only end up with 1, 3, and 5. Let me run the script and see if that's the case. Yep, there it is down here in the console in the bottom part of my screen. 1, 3, 5. That's right. Okay. So once again, it's a little hard to parse out, but it's helpful to look at this bit right here. Start with the for loop. Okay, we have for, and then we assign some variable in collection or list. In this case, it's a list. So we need to use I to refer to each one of these words in this list. And we say I for I to mean give me everything, but only if the current I, the current word, has an E in it. If E in I. Right, this I could be anything. This I could be any well-formed variable name. This could be cur word. And if I change it there, then I got to change these other I's to cur word. Current word, that's what I'm going for there, right? So whatever variable name I use here, I need to use here and here. This should work as well, just double check. Yep, we get 1, 3, 5 over here, down at the bottom part of my screen. Okay, so if I can pause the video, give that a try. Okay, let's take a look at the next one here. Rewrite the function above that filters words with the CV syllable at the beginning using a list comprehension instead of the for loop. So jumping back up to the previous exercise from the previous section, this said modify the previous program to print back to the user words that begin with the syllable structure CV, that is consonant vowel. You can actually write this in a list comprehension. Before we wrote it out in a for loop, but we actually could just go ahead and do a list comprehension. So pause the video and see if you can make that work. Ready, set, pause. All right, let's see a way to do that. This is more involved and gets kind of lengthy, but shouldn't be too hard to follow what's happening here. Let me pull this out a bit so we can see everything on one line. Okay, first we're going to import RE, our old friend RE. Then we have our list that has the 5 elements. And then here on line 4, we do a list comprehension. It's a big one, right? Once again, we start with the opening square bracket right there that's highlighted in yellow. And at the far right of the line 4, we see the corresponding closing square bracket highlighted in yellow. That's one big list comprehension with all this stuff in the middle. Once again, I'm going to highlight first what we see in for loops. We see for variable I, in this case, in collection list, in this case, this list of 5 words, right? And so that means we need I over here. Because we say I here, we need I here before it. So I for I in words. Then we do an if statement. We say if re.search finds this regex in I. Now, why is it I over here? Well, it's because we used I over here. We said I would be the variable name in this list comprehension. And that I holds each word in turn. It looks for each word in turn doing this regex search. And re.search returns two things. It returns a match object, but it also returns a Boolean operator, a Boolean value of true or false. So if it finds the regex in the string, it'll return true. And so we can use it as a Boolean value here with if. Okay, so if you find this regex, which is the same one we saw a little bit ago, I'm not going to review it. If you want to go back and find that in the video, basically we're finding a word boundary, consonant, vowel, alphanumeric character one or more times in the current word, which is represented by the variable I, because we use I right there. And don't worry about uppercase. Return that back out as a list and then print out that list. Let's go ahead and run this script. All right, we only have 2 words. We have 4 and 5. Yeah, because 1 begins with the vowel. That's not a consonant. 2 begins with 2 consonants, not a consonant vowel. 3, same deal, 2 consonants. But 4 and 5 have a vowel after the consonant vowel. So we get 4 and 5 down here in the console. Okay, once again, I don't want to hammer this, but I just want to make sure you're highly aware of whatever you put here, you need to use elsewhere in this list comprehension, like you do in a for loop, right? Whatever variable name you use for the variable in the for loop is what you need to use within the for loop body. Same thing here. If I were to put, current word here, I would need to replace these other I's with current word over here and over here and within re.search. If I run this again, it should give us 4 and 5 again. And it does. Okay, so if you'd like to pause the video and try and make this work on your end, that'd be great to do so now. Okay, so that is a quick rundown of how to do filtering of lists, which is something that is important. We'll see often where we get a big collection of something and we only want some members of it. So we want to filter out things. Another thing that we'll see, that we saw with list comprehensions at least, was how to apply a function or map a function. It's called map in computer speak, to map a function that is apply it to each member or each element of a list. We can do that with list comprehensions as well, like we just saw. All right, so hopefully now you should be able to filter lists with the conditional statement in a for loop, and possibly also filter lists with a conditional statement in a list comprehension. Okay, so that is lesson 4.2. We will see you next time.